Hello and welcome to helpyourmath.com. In this video, we're going to look at factoring expressions containing rational exponents. And basically, if you can factor a trinomial, you can factor these too. If you can't factor a trinomial, please stop this video, go watch videos on factoring trinomials, and then come back because you have to know how to factor trinomials in order to be successful here. Now, I'm talking about factoring a trinomial. We're looking at trinomials of the form ax squared plus bx plus c. And then what we look for, right, we look for any shortcuts that we can take. Is it something special? Otherwise, we do our target product, which is a times c, and our target sum, which is that middle coefficient b. What we want to do here also to be successful is we want to be able to write the first term as something squared. So we're looking to rewrite it so that we see that square, because when things look familiar to us, they're a lot less scary, and these can look very scary. So what do I mean? I mean we're going to take the exponent. So if we have x to the m over n, remember that we can rewrite m over n. So m over n could be rewritten as we can split up the fraction to 1 over n times m. And then once we have that, when we have an exponent and the factors are being multiplied, well, that was previously a power to a power. So this would be x to the 1 over n to the power of m. And so our goal would be to have this m equal to 2, or make sure that we end up with a square there to make our lives a little bit simpler. So if we can get that to be a 2, then we're going to be in great shape. Okay, let's look at our first example. We have x to the 2/5 minus 5x to the 1/5 plus 6. Looks scary, right? Well, let's first rewrite that first term so that we have something squared. And what do we have squared? Well, this would be x to the, we could rewrite 2/5 as 1/5 times 2. So we would say that this is x to the 1/5 squared, right? Because if we have those factors being multiplied in the exponent, that's power to a power, minus 5x to the 1/5 plus 6. Now this still looks really scary, and if you're still intimidated, we can use substitution to make our lives a little bit easier. So we can say, okay, you know what? Let's put a pause on the x to the 1/5, and let's say that x to the 1/5 is equal to a. So a is equal to x to the 1/5. That means anywhere in this problem that I see an x to the 1/5, I can replace it or substitute it with a. So it'll be a squared minus 5a plus 6. Now all of a sudden we have a trinomial that looks much nicer, right? So this trinomial, we have a leading coefficient of 1. So once we know the winning combination, we don't have to expand the middle. That's great. We know that our target product is positive 6 and our target sum is negative 5. So we're looking for two numbers that multiply to positive 6 and add up to negative 5, such as negative 3 and negative 2. We have to always be careful with that target product of 6 because it could go either 3 and 2 or 6 and 1. It all depends on what we're dealing with the signs. We have to be really careful with the signs. Okay, so now we know the winning combination, so we can write it in as a minus 3 times a minus 2. And then we say, okay, that's cool. But that's not what we were given. We weren't given a, we were given x to the 1/5. Oh wait, but a and x to the 1/5 are the same, so we can just substitute back and say, well, this is x to the 1/5 minus 3 times x to the 1/5 minus 2, and thus we have successfully factored our first very scary looking expression. Not so bad, right? So if it looks intimidating, just make it look less intimidating. If you can handle the weird rational exponents, that's great. You never have to use the substitution weird shortcuts that I use. It's not a shortcut, it's just a less scary version of the problem. How about this example? We have 4x to the 4/9 plus 12x to the 2/9 minus 7. Okay, so the first thing I want to do is I want to get that first term with that x to be something squared. So how can we rewrite? Okay, so I want to take 4/9 and I want to rewrite it as something times 2. So what times 2 is equal to 4/9? Well, that would be 2/9, right? Because 2 times 2 is 4. So we're going to think about 4x, and instead of 4/9, we're going to think about it as 2/9 quantity squared plus 12 times x to the 2/9 minus 7. So this works out well. We have the square, we have the 1, and then we have the no coefficient. Again, if this looks scary, use substitution. Just very temporarily say, okay, I know that b, or I'm going to say that b is equal to 2/9, just to make this a little bit less scary. This would be 4b squared plus 12b minus 7. And now we can just factor this trinomial. So this trinomial We can't take any shortcuts. I don't see anything special about this. The target product here is 4 times -7, that's -28. And the target sum is the middle coefficient, 12. Two numbers that multiply to -28 and add up to +12 would be -2 and 14. So we're going to expand the middle. We're going to replace +12b with -2b plus 14b, right? Because we forced this to equal that middle coefficient, 12. And then with that winning combination, we know that this is going to allow us to factor. So we're going to rewrite this as 4b squared minus 2b plus 14b minus 7. Now we're going to factor by grouping, and we have a common factor of 2b, leaving behind 2b minus 1. 14b and 7 have a common factor of 7, leaving behind a 2b minus 1. Now we see that these two terms have a common factor of 2b minus 1. So we end up with 2b minus 1 times 2b plus 7. Yay, we did it. No, we're not done yet. Just kidding. So now we want to go back and we're going to say, okay, b, we substituted b for x to the 2/9, so we're going to go back and write it, our final answer, with our x to the 2/9. So this would be 2 times x to the 2/9 minus 1 times 2 times x to the 2/9 plus 7. And thus we have successfully factored this next expression. Okay, wait, what's going on here? This is only two terms. Oh, okay, so let's just first get it so that the exponent is a square. So I'm going to rewrite this as 25 times x to the 1/11 quantity squared minus 49. If you want to use substitution, you can. I think for this one I won't, though. And what do we notice about this? There's only two terms. The GCF of the two terms between 25 and 49 is 1, so there's no common factors. But I do notice that 25 is a perfect square, and here we have a square, and 49 is a perfect square. And most importantly, we have a subtraction sign. We have a difference of squares on our hands. So remember what a difference of squares factors into? It's going to be root, that's a big root, minus root times root plus root. So we can just rewrite it. And again, if you're scared, use, c is equal to x to the 1/11, and then you would have 25c squared minus 49, which looks a lot nicer, right? And so then you could see there that we have a difference of squares, and you could factor and then substitute back for the x to the 1/11. But if you want to just go for it and jump all in without using substitution, that's what it would look like. This would be our final factored answer. In our last example, we have 4x to the 2/7 plus 12x to the 1/7 plus 9. Again, if you're intimidated, you know what to do. If you're not intimidated, we're going to say 4x to the 1/7 quantity squared, just because I like seeing that square. And one thing here, it has to work out that whatever this square is being multiplied to, or raising to the power of 2, this 1/7 better match this. If those don't match, this won't be factorable, right? Because if you tried to use substitution, you wouldn't be able to substitute two things that aren't the same, so it wouldn't work. Okay, so that was my little rant on that. That's over. We're all done with that. Now, what do we see? We have 4, 9. Wait, this is a perfect square. It's not a trinomial, but it is a perfect square. So this is going to factor into, this would be 2 root, and then because this is addition, this would be plus root quantity squared. So we could just do that. If you didn't recognize that, you could of course do target product, target sum, and you should end up with 2 of these factors. And of course, if you want to, you could say, okay, well, I'm going to just say that d is equal to x to the 1/7, and then work 4d squared plus 12d plus 9 instead. And when you do that, you should end up with 2d plus 3 quantity squared, or 2d plus 3 times 2d plus 3. And no matter which way we do, we should end up with 2x to the 1/7 plus 3 quantity squared. These have been examples of factoring with rational exponents. Thank you for stopping by.